Hey everybody, I hope you're staying safe at home and not doing anything that you don't absolutely have to do. So here are going to be some quick notes for us on the second supplemental topic in this section. So I'm just going to label them supplemental topic number 2, but this is part 1. I know that's confusing. There are 2 parts to these topics. These are not actually included in our text. So we just call them supplemental and we divide it into 2 different parts because they're pretty much interrelated. So we begin with the fact that expected value is the first section, and the expected value is referred to as the center of the probability distribution. And it also is referred to as what to expect. So if somebody asks you, like, what is the expected number of red lights you're going to hit on any given morning, right? Like, they're actually asking you to find the expected value of something. So there are a few follow-up definitions that might be relevant for our Pearson homework. So we're going to begin with the discussion of the random variable. So a variable, we know, is one of the pieces of information that we gather, right? So in this case, it's a numeric value that's based on the outcome of a particular random event. So a numeric value based on the outcome of a random event. Typically, we use capital letters to represent these. So in my examples, I almost always use the capital letter X. So I'm going to say capital letters and we use the letter X, okay? So I love this section because I like to make examples about gambling, and I think it's just exciting and a lot of people can relate to it, and for the most part, people understand winning and losing money. So for the random variable, let's say if we were doing a gambling example, a numeric value that's based on the outcome would be like, if I, for instance, win money when I'm playing a game, then the numeric value would be the money I win when I win the game and the money I lose potentially if I am losing any money when I do not win the game. So there'd be different values based on the outcome of the event, in terms of the event being playing that game. Okay, so we have 2 different versions of random variables. Basically, we want to distinguish between whether or not we can list all of the outcomes or not. Okay, so the first thing here we're going to do is figure out the difference between discrete and continuous in the context. Sorry, I was getting a bunch of texts from my family. In the context of what we need to understand, okay? So we have discrete random variables and continuous random variables. And both of them are talking about this numeric value. And we really only focus on the discrete. So this is what we're going to be focusing on. But in this case, it is possible to list all outcomes. So in these examples, we want to make sure we're addressing examples where I can list all the potential outcomes, and that's why I discussed just previously something in which I win or I lose. Now, the continuous random variable is, I don't know why I just did that, it's not possible to list all of the outcomes, right? So it's not possible to list all the outcomes. All right, and I want this to ring true because we're going to have some questions potentially on the online homework where they're just listing specific variables and deciding whether you believe you can actually list every outcome or it's a continuous and likely infinite, right, list of outcomes. So that would be what we're differentiating between. And then finally, the last thing I want to add before we talk about what the actual expected value is the definition of a probability model. Okay, so I'm going to move back out here and say a probability model is the collection of all possible values. So the collection of random variables and the probability that those values occur. So it's the collection of all possible values of the random variable and the probability they occur. Okay, so when we make these little charts, I write them looking like this. All right, I'm going to write that here. I usually write words for the outcome, right, so that I can put it in words, like maybe for the example that we just did, maybe something basic like win or lose, where there's like only two options. And then we list maybe the amount of money that we would win or lose. And then next to that, we would actually list the probability of each one of those events. So just to put it into context, this little table I created, next to win and lose, there would be two separate values. One for the money in this column, so the dollars would go here, right? Let's put double dollar signs so you see what I'm doing. And then some sort of decimal would go in here to represent the two probabilities, one of winning and one of losing, and making sure they are in probability, following probability rules, i.e. they're between 0 and 1. Okay, so I need another page. So let's see if I can do this. No, I want to, great, add another page. Okay, so it looks like what I have to do is actually clear the recording, which I'm not really sure that I like, and then start over. So that's why I'm doing these videos, and you guys can follow along at whatever your own pace is. So right now, go ahead and just pause the video and make sure you have all the notes that are on here. And I'm going to go ahead and clear what's on here so I can start fresh for the probability model. I'll remake that little table, okay? So remember that we're talking about a probability model and our table should look something like, I'm just going to recreate it over here where we have our outcome. Sometimes when we're doing these problems and other people are creating them, right? It doesn't use the word outcome here. Maybe it says what we're talking about, like results of the game or something like that, remember? And then we have an X column and a P of X column that all include values. Usually our outcome is expressed in words. So I want to talk about the two requirements that make a valid probability model. Okay, there are exactly two requirements that we need to think about. The first requirement is that all of the probabilities that we have in the probability column, I'm going to write it in a little equation first, fall somewhere between 0 and 1, okay? So first I wrote that in an inequality, and then I'll write it in words right next to it, okay? All probabilities fall between 0 and 1, okay? And then the second thing that we're always checking for is whether or not, whoa, I did not mean to enlarge everything, guys. Obviously, I'm new to this. So the second thing we're discussing is whether or not, I actually don't know how to make it go back, so I obviously need to work on some stuff here. We need to check whether or not the sum of all the probabilities here equals 1, okay? So what we mean by that is when we add up all the values in the P of X column, right? Add them up, and check if they're equal to 1, right? That's what this is saying. So I'm going to write that in words. All P of X sum to 1, right? So they add up to 1. So if we create a probability model and these two facts are true, then we will have made a valid probability model, okay? So last thing I want to add is our definition of expected value, okay? And again, let me just see if I know, oh God. I don't really quite know how to zoom in or out here. So I'm going to add here, and then I'm going to do a little bit of research before I make my next video for notes. So I'm going to circle back to the term expected value, which we already said was the center that some people referred to in the probability distribution. And most people refer to the center in many distributions as the mean. And in this case, that's correct. It is technically the mean, or X bar, okay? So this is the mean of the random variable with respect to the probabilities that are given to us. And again, we use the term like it's what to expect out of the problem, okay? So if it's a gambling problem, it's how much money I might expect to win or lose. Again, it could be anything. How many years I expect my college degree to take me, how many days I expect to be quarantined in my house. I don't know any of the statistics on that, but maybe we could look into that stuff to make this reasonable and relatable. But just so we have a context of what this looks like, remember that in our little picture up top, this is like a capital X right here in this column before the P of X. So I have outcome X and P of X. And the expected value here is, this app is terrible. Whenever I put my hand on the app, it writes a little mark. So I apologize for that. But the expected value is denoted E of X. Okay, so E of capital X. And that's the same as the mean, or what to expect here. Okay, so this is found pretty relatively straightforward, but the equation looks kind of ugly. So the equation here, it looks like this. It's the sum of every X times each of the P of X's. And this is kind of ugly looking, right? But I multiply each pair of X and P of X. So I literally multiply the value I put in the X column times the value I put for its P of X. And I add all the values together. And I add these together. So in the previous example on the other page, when I had said win or lose, I would have had exactly two things that I add together. All right, and then there's actually a way to find this in our calculator. So I'm going to go ahead into calculator commands, because that's the only way I'm actually going to teach you guys to find the standard deviation. As you know, we don't do standard deviation by hand. So the calculator commands here would be that we would enter all of our X into list 1. Then we would enter our P of X's as like either decimals or fractions into list 2. And what we would do with that information is we would go to stat, arrow to the right, and we would run one var stats. But then you'd want to kind of stop there, because for some of us, we have an older calculator, and for others, it's the newer calculator. And I have not quite figured out a way to do the calculator stuff yet. I am relying on the videos that are already on Canvas for the moment. I am trying to work on how to get the app to show up on here with the screen that I have. So at the time being, because I'm not as tech savvy as I wish I was, I'm going to give you the two options, okay? So the first option is, for my old calculator people, it looks like one var stats, and then you have a blinking cursor right next to that. Well, you're going to need to type L1, comma, L2. Like, actually type the comma in your calculator. And the way you get to L1 is by hitting second and then the number 1. And then this is second and the number 2. So it's second 1 and it's second number 2, right? And then the second option is if you have a newer calculator, it's 1 var stats still, but you end up with like an X list, which you want to set to list 1. It should be the default. And the second row for you says frequency, which is where you want to put L2. And then for everybody, we would go ahead and hit enter. And I'm just going to move right next to this note over here, right? E of X would be our X bar. And then our standard deviation of, let's say, capital X is our, oh shoot, I just wrote S, but what I meant to write is sigma. This is the one time in class we ever use sigma of X. If you just did this in your calculator, not that you have any data to do that with, but if you just did these two things, then you would see actually when we do this 1 var stats and we put the probabilities into list 2, that we don't get an output for S. We only get a sigma value. So we do want to remember that we're looking for sigma in this one instance. And those are my notes on expected value. I will now make sure that there's an expected value example video, so you can go ahead and take a look at that as well. Good luck.